Okay, so in example 2 here, it says to find the following. So on this first example here, what we're trying to find is the exact circumference and the exact area. And that word is kind of important in there, exact, because if you look at those formulas, I have 2 pi r and then pi r squared, right? And so when we've been computing like these formulas in the past, we always use 3.14 to represent pi, but that is an approximation, all right? So when it's asking you for the exact circumference in the exact area, what we're going to do is we're going to keep it in terms of pi, which means that we aren't going to use 3.14, all right, in for our formula. We're just going to keep it with the pi in our final answer. Okay, so if you look at this first example, it says to find the exact circumference, all right? And I'm going to use, in this example, C is equal to pi d. So that means if I can find my diameter, then I can find my exact circumference. So I'm looking at this picture here, and I'm going to notice that I have this triangle, all right here in my picture. So I have this triangle. And I know that this triangle is a right triangle because I have that 90 degrees in there. And even more specifically, I know that it's a 30, 60, 90 triangle because I had the 90 degrees and the 30 degrees. And so what I'm going to use now, connecting back to last chapter, is I'm going to know that this 2 is going to be my short leg. And what I'm trying to find, all right, in this picture is actually this segment right here, which is my diameter. But in this picture, it's also my hypotenuse. So if we remember our 30, 60, 90 formulas, all right, our hypotenuse is equal to 2 times the short leg. My short leg is 2, so I'm going to have my hypotenuse is equal to 2 times 2, which means that my hypotenuse is equal to 4. And now, just really quickly, I'm going to take this 4 and I'm going to plug it in for my d here. And remember, I'm going to keep this in terms of pi. So then my circumference is equal to 4 pi. And that's my final answer. All right, let's try the next one. So this time I'm finding the area. So again, I'm going to be using A is equal to pi r squared. Okay. And for this one, I have to find the radius, okay? So if you look at this picture, again, I have this triangle in here, all right? And in this triangle, I know that it's a 45, 45, 90 triangle. So there's my picture, all right? And what I'm given here is a leg. And what I want to find is the hypotenuse of that triangle, okay? And we'll talk about what we have to do after that. But our formula for that is hypotenuse is equal to the square root of 2 times the leg. So I'm going to take this 3 square roots of 2, all right, and I'm going to plug that in for my leg. So I'm going to have the square root of 2 times 3 times the square root of 2. Simplifying that, my hypotenuse is going to be equal to 3 times 2, which means that my hypotenuse is equal to 6. So this full segment right here is 6. Now, that means that my diameter is 6. And what I need to find, all right, in my formula is I need to find my radius. So that means that my radius is equal to 3. So taking that 3 and plugging it in, all right, I'm going to have A is equal to pi times 3 squared. I'm going to square the 3 first, so I'm going to have A is equal to pi times 9. And again, we're keeping it in terms of pi because it's the exact area. So my area is equal to 9 pi. Okay, so our next term here is congruent circles, and it says circles that have congruent radii, all right? So for circles to be congruent, it's actually based off of their radii length. So if I would, in this picture area, all right, draw my circle, okay? I'm going to draw in my center, And then again, I'm going to draw in my radius. Okay? And let's go ahead and say that this is circle M. Now, I'm also going to draw another circle that appears to be the same size. Okay? I'm going to draw in my center and then draw in my radius. I'm going to have it going this way now. And let's call this circle R. And for these two circles to be congruent, we would need to know that these two radii, bam and bam, are congruent. All right, and so if we know that the radii are congruent, then we're going to know that the circles are congruent. So if I wanted to write a congruency statement, I would say that circle M is congruent to circle R. And this is actually really important in future lessons, all right, for us to be able to say that if these circles are congruent, then we know that the radii are congruent. Okay, so the next one says the inscribed polygon. So what an inscribed polygon is it's a polygon whose vertices lie on the circle, all right? So I'm going to go ahead and draw a circle in this. I'm going to make it a pretty big circle, all right? And if I wanted to inscribe a polygon within that circle, all right, what I'm going to do is I'm going to make sure that all the vertices are on that circle. So if I wanted to inscribe let's say a pentagon, so a 5-sided figure, all 5 vertices have to be on there, all right? So I would have to go ahead and put this segment. So right now I'm at 2 sides, 3 sides, 4 sides, and then 5 sides. And if you notice, all 5 vertices lie on the circumference of that circle. So we would say that that pentagon is inscribed inside that circle. So example 3 then says, a square with a side length of 9 inches is inscribed in circle J. Find the exact circumference of circle J. Whoopsie. All right, that should say circle J. So we know that it's a square. So again, all of these are right angles, okay? And we need to find the exact circumference. So we could do this multiple ways, but I'm going to recognize that if this is a square, all right, then what we're doing here is we're making 45, 45, 90 triangles, okay? So these are 45, 45, 90. This is also 45, 45, 90. And what we're just going to focus on is this triangle right here, because we have a 45, 45, 90 triangle. And what we need to find in order to find the exact circumference is we're going to use C is equal to pi d. So I need to find my diameter. So looking at that blue right triangle, all right, I have my leg, and what I'm trying to find is my hypotenuse. So we could use Pythagorean theorem here, but I'm going to go ahead and do that the hypotenuse is equal to the square root of 2 times the leg. And I'm now just going to take that 9 and plug it into my leg. So I know my hypotenuse is equal to the square root of 2 times 9, which means that my hypotenuse is equal to 9 times the square root of 2. And that's my diameter. All right, so what I just found there was my diameter. So I'm going to take that 9 squared to 2 and plug it in for my d right there. All right, so my exact circumference, again, we're keeping it in terms of pi, is this going to be 9 squared to 2 pi. Or even prettier, all right, you could write it as 9 pi times the square root of 2. All right, either of them are fine. All right, just make sure that you don't tuck that pi underneath the radical, okay? All right, so I'm going to pause there. And then, so that actually was section 10.1, and now we're going to go into section 10.2.